On my blog at http://solarcities.blogspot.com/2009/biogas-water-heating.html, I have posted the formula for biogas water heating, which is the standard physics formula where you calculate how much water at one temperature do you need to add to water of another temperature to get bath temperature water. And the formula is, of course, the temperature of the final water that you want, which should be anywhere between 32 and 40 degrees, depending on how hot you like your bath, given that your body is 37 degrees, equals the mass of the first body of water times its temperature, plus the mass of the second body of water times its temperature, divided by the two masses of the two bodies of water added together. So there's where we have TF equals M1 times T1 plus M2 times T2, all of that divided by M1 plus M2, and of course, since water is 1 kilogram per liter, if you know the number of liters, you know the mass. So 1 liter is 1 kilogram. And this formula then, when put into a calc spreadsheet, calc is the open office version of Excel, then looks like this. There's the formula right there that you can type in, where B2 is mass 1. So we can see that if we assign cell B2 to the first mass, and cell C2 to the first temperature, cell D2 to the second mass, and cell E2 to the second temperature, then the formula goes in as B2 times C2 plus D2 times E2 divided by B2 plus D2 gives you the final temperature. And now when we go ahead and put the values in, remember that what we had was, we had 2 liters, that's 2 kilograms, of 82 degree water by the time we got to it, and we had 5 liters, which is 5 kilograms, of 17 degree water, which is the way it came out of the tap. And when we hit return, we see that in fact what we should have gotten was 35.5 degree water. We saw 33, 32. It was adjusting, of course. This, of course, is because of thermal losses. Even as we were pouring the 82 degree water into the bucket that had the 17 degree water, heat was escaping both to the air and to the walls of the bucket itself, which was cold because we just brought it in from outside. And so when you look at the formulas, they're looking at ideal conditions. But the point that is illustrated here is simply that one can understand in poor communities how bath water is heated and see how biogas could help with this. In general, a family might take 5 liters of water and heat it up to 90 degrees, and then take an additional 15 liters out of the tap, which is at 17 degrees. And as you can see with that, you would have 20 liters of 35 degree water roughly. You might have some losses, but still anything between 32 and 35 is very comfortable. And that should certainly be doable with the 1,000 liter biogas containers. In fact, you should be able to heat twice that, since you get sometimes as much as 2 hours of biogas a day. With 1 hour, one could certainly achieve this. And in most of Cairo, in the sample that I took in both Darb al-Ahmar and Manshiat Nasser, 20 liters per person for a hot bath was an average and was fairly standard. And this can be achieved, once again, either by heating the entire quantity or by simply raising 5 liters up to 90 degrees. We'll do another experiment to see if it's more efficient to heat the entire 20 liters up to 35 degrees, or whether one should heat the smaller quantity and then add it to the tap water. But that is the idea here. This is not one of the more exciting videos, I realize, but I hope that this has helped some people understand how biogas might be used to heat bathing water, even in small quantities.